Hello, and welcome to our senior design project, Healthcare at Play. I'm your handsome and charismatic host, Nick, and I'm going to be leading you on an educational journey of a lifetime through our amazing prototype. This feat of engineering ingenuity is able to measure the movement in the patient's hand as they bend and flex their fingers. This data is then sent into our fun and interactive game, which aims to incentivize our patients to continue using the product. The end goal of this is to minimize the negative effects resulting from hand arthritis through the usage of daily exercises. Let us now delve into the intricate complexities of our design.
Here is short flex sensor prototype, and as you can see, this club right here have 6 sensors on that, which able to capture the bending ability on finger. Especially they have 2 flex sensor on thumb, which allow to measure the bending angle in 2 dimension on thumb. In normal one, they reporting 180 degree, but when you're bending the angle down, the reporting data is going down, and in the opposite direction when bending angle up, the report data should be above 180. The wire in here is connecting to the red box in this. The red box is a 3D housing printing. This have the cap on the top, which allow to protect the circuit in the side, and this cap also able to remove to update the circuit when needed. This circuit, it connect directly with the Arduino below it, so that is let us able to reading the data from the sensor and understand the trending of the motion.
But wait! When you order now, you'll also receive a free gift with your purchase. This bonus prototype uses the power of magnetism combined with linear Hall effect sensors to detect the position of each individual finger. That's diabolical! This prototype operates by utilizing linear Hall effect sensors. These fantastic gadgets are able to sense the strength of a magnetic field at their position. By placing one of these on each of our fingers, along with a magnetic source on the palm, we can track the motion of a user's hand. Let's take a closer look. As previously stated, this prototype uses Hall effect sensors. Underneath each of these sewn tabs on the finger is a Hall effect sensor. As you can see, the thumb contains 2 Hall effect sensors to measure 2 directions of motion. Underneath this center fabric is our magnetic source. As our sensors move closer to the magnetic source, they experience a field with a greater strength. This will change our output to indicate the distance from our finger to our palm. To utilize our second sensor on the thumb, we also added an additional magnet on the side of the index finger. The signal from this is then sent into our circuit board, which contains a RC low-pass filter. As the signal is sent into this filter, it goes through a resistor and a capacitor in series. The output of this is taken from the capacitor to ground. As the signal is fed through here, the capacitor will work to eliminate any high-frequency noise we may experience in our outputs. From here, our sensor is sent to our Arduino microprocessor, which relays it through the serial port to our computer. Now that we've gone through the hardware, let's take a closer look at the software, starting with our fun and interactive game. Developed on the Unity platform, which operates using the C# programming language, our game is able to give an on-screen representation of the user's hand via the data transmission of our sensors.
For the game portion of this project, we use Unity version 2020.2.6, which uses C# as its programming language. After we plug in the Arduino via USB and configure the glove, we can play a pose matching game to measure the flexibility of each finger. The current game cycles through the digits 0 through 10 in sign language, with some slight randomness. After the game is complete, the data will be saved to a local file which can be uploaded to Spotfire for analysis.
The second portion of our software utilizes Spotfire, a spectacular program provided by our sponsors at TIBCO. Using Spotfire, we can create a visual representation of the data collected throughout our game, which can be viewed by either our patients or our patients' physical therapists.
Spotfire helped with the analytics stage for our project. The raw data from the gameplay was easily uploaded to Spotfire and laid the data out so all of the desired data needed is selected for analyzing. So what we have displayed here is our raw data table uploaded directly from our gameplay. The data table includes the actual pose alongside with the target pose for each finger. A simple percent difference calculation was made to see just how well the player did. Once we made that calculation, we used Spotfire's visual representation tool to create a box plot as shown. The goal of the game, and for the user to see just how well they did, is to be as close to the value 0. Being closer to 1 shows the user they flexed too much, and being closer to -1 shows the user they didn't flex enough. As you can see, the user did pretty well with their pinky, ring, middle, and index finger, since the first and third quartile markings show very small margins. As for the thumb, the values have a pretty wide range, and this tells us that the thumb had little mobility or there was an issue with the sensor itself. Thank you.
Wow, that project was pretty amazing, wasn't it? Now remember, our engineers operate on a tip-only basis, so feel free to show any monetary appreciation at the end of the film. That's all for now, folks, and don't forget to join us next semester when we create a giant space laser.